Okay, let's take a look at finding the limit as x approaches 0 of the function x cubed plus the cosine of 5x over 10,000. Now, I'm leaving these tables here, but I also want to use the calculator to find out what's happening. So let's go ahead and put this function into our graphing calculator. So we'll go to y equals, clear our graph, and we have parentheses x cubed plus the fraction cosine of 5x divided by 10,000. So let's go put in our table of values. So let's put in negative 0.1, negative 0.01, negative 0.001, 0.1, 0.01, and 0.001. Okay, so let's take a look at more of what's happening. So I'm going to take a picture of this. Okay, and I just want to investigate these values that we just created here. Okay, so when you take a look at negative 0.001, okay, the output here is 1 times e to the negative fourth, right? And then we also have 9.9 e to the negative fifth. Okay, so let's take a look at this number here. So keep in mind that we're talking about a scientific notation number, because this is the same thing as saying 9.9 times 10 to the negative 5. And so we're going to shift to the left the decimal places 5 times. So we should end up with 0.00099. Okay. Now, if we round this to the nearest decimal, so now if we round that 9 for this 0, then this is approximately 0.0001. Okay, now how do I write that as a fraction? Well, we know the 1 is in the 10,000th place. So this is actually 1 over 10,000. Okay. Now, by constructing this table and seeing what's happening with these numbers, okay, as it's getting closer and closer to 0, we can say that this limit as x approaches 0 of the function x cubed plus the cosine of 5x over 10,000 is equal to 0.0001, which actually ends up equaling 1 over 10,000. Okay. Now, these two examples, example 4, okay, and example 5, okay, they illustrate some of the pitfalls in guessing the value of a limit. So it's easy to guess the wrong value if we use inappropriate values of x, but it is difficult to know when to stop calculating values. And as the discussion after example 2 shows, sometimes calculators and computers give the wrong values. So when we talk about the next section, however, we will develop foolproof methods for calculating limits, because right now we're just guessing according to our table of values.